Okay, let's take a minute to review what the z-score is. It tells us, the z-score tells us how many standard deviations a value of x is above or below the mean. So it gives us a distance from the mean for an x value. Okay, so if we have x values that are larger than the mean, that would be here, right? Maybe, right? Values that are above the mean to the right on the x-axis, right? Or on the number line. These are going to have positive z-scores, okay? And then if we have values of x that are smaller than the mean, right, or they fall to the left of the mean on that number line, they're going to have negative z-score values. And then, of course, if x equals the mean, then its z-score would equal 0. Okay, just like a number line, a real number line. Okay, so let's have a look at this example. If we want to find the probability that a normally distributed random variable x would lie within 2.5 standard deviations of its mean. So here's its mean, right? And so 1, 2.5. So we're looking at 2.5 standard deviations away, okay, from to the left and to the right. By definition, the z-score gives us the number of standard deviations away from the mean. We can go ahead and we'll say this is already in terms of z. So negative 2.5 here, all right? Positive 2.5 over here. Okay, and this x value is located somewhere in this vicinity between these two values. So what we're looking for is the probability, okay, that z is between negative 2.5 and positive 2.5. And this is how I'll write that out for now. Okay. So the area we're looking for, remember the area under this curve between these two values is the probability that we're looking for. So let's go ahead and that area shaded, what we're looking for. There you go. You can shade it with your pen on your paper. I do recommend that you try to shade in on your paper. Try to sketch out a normal curve and fill in these values on your own to kind of formulate the probability problem that we just wrote over here. And we're going to work on that more in a minute. So leave a little room under the probability statement. I just want to take a minute and remind you that these normal curves are symmetrical, right? So the area that we have shaded here on the to the left of the mean will be equal to this area that's shaded to the right of the mean within our boundaries here. Okay, so we're going to use the fact that we have symmetry. Of course, we know that the entire area under the curve is equal to 1. So really, we can focus on finding this area, which is the probability that z is located between 0 and 2.5. And then on the left, we say probability negative 2.5 less than or equal to z less than or equal to 0, right? And that is equal to the probability of 0 less than z less than or equal to 2.5. So we're going to have the same area on the left of the mean and on the right of the mean. We want to have the probability between 2.5 and 0, right? And then plus we want to have the probability from 0 to 2.5. And these are actually going to be the same thing. So what I can do is just find this value from 0 to 2.5. And here's why. Because I'm using this standard normal table. Okay, and this particular table gives me the values between 0 and z. So it's giving me this area, which is good because I want 2 of those, right? I'll take 2. Okay, so on this particular table, what you'll notice is we have the first two digits, like 1 point, the units and the tenths is on this column, and then along the top is the hundredths place. For probability, we're 0 less than z less than equal to 2.5, and we'll put a 0 in there for the table. We'll go here and find 2.5, okay, and then 0 up here. Okay, and here is where those two things intersect. And here's that probability. So this probability, which is just from 0 to the 2.5z, right? That's just that right side of what we're looking for, according to the table. And if you put this in your calculator, this is what you should get to, 0.4938. So that's half of our math done, right? Let's go back up and just remember 0.4938. Let's go here. So we know that we have 0.4938. And over here, since it's symmetrical, right, we have the symmetry 0.4938. If you want to put your 0, and go ahead and add those up, and you'll get this total area that we're looking for. Right, and you should have 0.9876 for our total area. And that is the probability that a random variable that's normally distributed would lie within 2.5 standard deviations of its mean. Remember that the z-score gives us the number of standard deviations, and in this problem they tell us that this value lies within 2.5 standard deviations. So right there we get our z-score. Okay, I hope this has been helpful, and let me know if you have any questions. I'll talk to you guys soon.